This is Michael from Blue Sky Bio. I'd like to welcome everybody who's joining us for tonight's webinar presentation. Tonight's presentation is the first of a webinar series that we're running during 2017. We have many different webinar presentations scheduled, averaging around 1 or 2 every month, around once every 2 weeks or so, on a wide variety of topics connected to placing implants and guided surgery. We have a great lineup of fantastic speakers and great topics. And this year's webinar series is really the first time that we're going to be presenting webinar presentations in different languages and timed for different time zones for different countries throughout the world. So stay tuned for information regarding upcoming webinars. The information is on the Blue Sky Bio website. And of course, we send it out via email as well. The webinar series is also being presented in conjunction with biobigbox.com. BioBigBox is a HIPAA-compliant file transfer and storage system developed by Blue Sky Bio. And for the webinar series, we're offering a 50% discount code for new users. You could go to biobigbox.com, use many of the features and functionalities at no cost. And then we have paid options for additional functionality and more storage. The coupon code is BSB 2017 webinars. So that's what could be entered during the checkout process. And you can contact us if you have any questions about that. Just a note, we've uploaded a new build, a new version of Blue Sky Bio to the Blue Sky Bio website. So anybody could go and download it on top of the version of Blue Sky Bio that you have on your computer. Many new features and functionalities. I'm actually going to be giving a webinar presentation next week on how to use some of these new functionalities within Blue Sky Bio. Please make sure to enter your details into the webinar attendance form so we can send you the CE credit. The link to the form is in the comments box next to the video windows. If you have questions during the presentation, then you can go ahead and type those in, and we'll hopefully get them addressed during the presentation. Tonight's speaker is Dr. Rick Ferguson. He's the Director of Implant Educators. I don't think he needs much of an introduction. He's very active in the different Blue Sky Bio channels, very involved in commenting and new builds and features for Blue Sky Bio. He's trained thousands of dentists over the past 2 decades or so, and he lectures throughout the world on a variety of different topics. So I'd like to pass the stage over to Dr. Ferguson, who's going to be lecturing on the essentials of in-office 3D printing guides, where to start, what to buy, and how to use this technology to make your practice more profitable and efficient.
Michael, thank you so much. First of all, let me thank you for inviting me to present this evening, and let me also congratulate you and your team on developing and constantly improving and evolving the Blue Sky Plan software. It's really tremendous how far it's come, especially in the last couple of years with all the latest builds that allow us to do some really amazing things in office with 3D printing, and also some of the things I'm going to be talking about today, incorporating some of the hardware and allowing practitioners to really use a minimal amount of hardware to plan their cases and produce surgical guides. So kudos goes out to you and your team at Blue Sky Plan and Blue Sky Bio. Thank you again. Today, I'd like to start off with basically where you start. So one of the things that, you know, since I've gotten involved in really educating people on using software and using it to create surgical guides in office with 3D printing, I've realized that where people really need to start is with a comprehensive implant training program. A lot of the problems and the questions that I get have led me to believe that a lot of people out there, you know, have piecemealed their education, and they don't really have a format in which they do things. They sort of got into it haphazardly. So I do recommend you take a comprehensive implant training program. Obviously, we have one, but if you don't take ours, take somebody's. And it's get into a program where they teach you not just how to place implants, but how to plan cases start to finish, and how to develop the case and treatment plan it properly. So I think that's where a lot of people should really start who are getting into implant placement. Obviously, we have our own program. This is our brochure. We have a 7-month program where we teach all aspects of implant dentistry. Our goal at our program is to teach all of the different restorative options that you see on the screen here. From socket grafting and single implants to overdentures and hybrids and advanced bone grafting procedures. Even if you don't plan to do these procedures, at least you'll know how to treatment plan them and how that affects what you're doing in the Blue Sky Plan software as far as the prosthetic outcome. Because everything that we do today in implant dentistry should be based on the prosthetic outcome. So I think folks need to get a comprehensive training and know all the options so that you're treatment planning your cases from the prosthetic point of view. And again, our goal at our implant training program is to have everybody leave at least knowing how to do and also how to treatment plan all of the procedures you see here. Our program is unique in that we run it with the University of Florida, and we can bring doctors from any U.S. state. Any U.S. licensed dentist can come and actually do these procedures at our course under our supervision. These pictures that you see are all from cases that were done by the doctors at our course. We have a full lineup of speakers and experts in all the various disciplines of implant dentistry. But one of the things that we're most proud of is that we're probably the only course in the country where every case that we do is done with a surgical guide, is planned in 3D, and is done with a surgical guide according to the recommendations from the American Association of Oral Maxillofacial Radiologists, their position paper in 2012, that 3D imaging should be used for all dental implant planning. And we go one step further and have all of our cases done with surgical guides. Of course, the thing that I'm probably most proud of is our private practice. My wife, Dr. Catherine Ferguson, and I have a small private practice in Davie, Florida, which is a suburb of Fort Lauderdale. And if anybody's ever in town and want to stop by, please give us a call, and you can see how we put into everyday use the things that we teach and that I'm going to talk about today. So, what to buy? This is a thing that I get a lot of questions on, and when Michael asked me to do a webinar, I thought I would put together an outline of where to start and what to buy with 3D printing, in-office 3D printing today. So of course, you're going to need some hardware. You're going to need a CBCT, a guided surgery kit is very useful, a 3D printer, computer, of course. And then of course, if you should probably take a course, a 1 or so more day course on actually using all of this technology. You'll notice that the only thing on here, though, that's really of no cost or significant cost is the Blue Sky Plan software. So that's where all of this actually begins. But of course, today we're using 3-dimensional imaging, and you need the CBCT image. Now you can get a CBCT unit today at a very, very reasonable price, about $70,000 for an 8x8, and that's what you should be looking for, is a minimum 8x8 field of view. That's what you need to plan surgical guides. You need a full arch in order to do the STL alignments properly in order to make accurate surgical guides. Now, if you really want to do this on a budget, let's say you already have a CBCT or you have access to one, and you use a digital impression technique where you scan a standard VPS impression with the CBCT unit, and you opt not to get an optical scanner. You opt to use your existing implant kit, which would probably not be a guided surgery kit. So basically what you're talking about doing here is just making a pilot hole, not a fully guided procedure. You get a 3D printer. Let's say you get the most reasonable one out there that allows you to do guided surgery, which is a Robox, which you can purchase at blueskybio.com. You're talking about $1,500. Let's say you use your own computer that you already have, and I'll talk about computers in a little bit. and you're smart enough or technical enough to go online and figure out how to do it all yourself, which there's certainly a lot of people out there doing that, and you forego a course that teaches you how to use all the software and hardware. You could literally get into this and print your own guides in Office for about $1,500. And what that gives you is the ability to produce a surgical guide for about $20 per guide. That's including the export fee from Blue Sky plan, which is around $15 or so. But the raw materials to print the guide with the Robox printer is literally about $1 for a quadrant guide, and maybe $2 for a full arch guide. Now, this is going to cost you in another way. You're going to be looking at actual time spent in the software to be about 35 to 45 minutes. And you'll see how, buying additional hardware can help reduce that amount of time. And as they say, time is money. But if you have the time and you don't have a lot of financing, you can certainly get into 3D printing your own guides for very low cost, thanks to Blue Sky Plan and the Robox, which is something that I developed for guided surgery, in-office guided surgery. We'll talk more about that in a little bit.
I could just jump in a second and add in a small plug. We've recently started carrying the CareStream CBCT and intraoral. Just a comment that we're packaging it together with printers and many other items which will help doctors get up and running, both with the implant placement and with guided surgery. So just another option. There are many fantastic CBCTs out there, but if you're interested in considering the CareStream, we're packaging it and bundling it together with the printer and many other items as well on our website.
That's right. And when you package things in a bundle, of course, your cost savings are so much better. Thank you, Michael. So what to buy? Let's keep going here. What I do highly recommend is buy a guided surgery kit. I know a lot of people start off doing pilot guides, but they're not as accurate, and you'll certainly benefit tremendously from getting a guided surgery kit. And that's going to increase your cost a little bit to, say you buy a guided surgery kit for $3,500, you're looking at about $5,000 now total expense. And then again, this still allows you to keep your guide cost to about $20. But again, your Blue Sky processing time as far as working with the software before you actually send it to the printer, it's going to be about 35 to 45 minutes. One note on why I believe that you should use a guided surgery kit. And here again, they say a picture is worth 1,000 words. If you look at this image here, this is a post-op CBCT image of a case that one of my colleagues did last week, actually, where she drilled a site for the implant, and this is in the aesthetic zone, maxillary anterior. She drilled a site using a surgical guide, and everything went great. But then the implant was placed freehand, and you can see what happened. It actually went off the trajectory and ended up through a buccal plate. So my advice to her was to actually remove the implant, place the guide back in the mouth, and then place the implant back through the guide. And this was the result after she had done that. So even though we can certainly drill sites using surgical guides, I think if you want the maximum amount of accuracy with your implant placements, you should also be placing the implants through the guide. So when you're looking for a guided surgery kit, you want to look for one like this one from Blue Sky here, where you can actually not just drill the site using the guided surgery kit, but also place the implant through the guide, which will increase your accuracy tremendously. So just another little tip there. So I do recommend you, spend the extra money. It's certainly worth it. It's not worth the headache to, basically drill the site and then, place the implant, and then the implant's a little bit off axis. Of course, it depends on where you're placing the implant. If you're placing it in the posterior where you have a good triangle of bone and the position at the apex of the implant is not as critical, then certainly freehand placement might be adequate. But if it's in an area where it's critical, that the position of the implant is critical, then you might want to certainly think about using the guide also to place the implant. And this is allowable with the Blue Sky Plan software. So we mentioned the Robox. That's really the least costly, the most economical way of getting into printing guides in office. And let's look at the other option, the really only other viable option that's out there as far as in-office guides, due to the cost of the more expensive dental type 3D printers. If you look at the Robox versus a Form 2, you can see the cost is significantly low in the Robox, $1,500 versus $3,500, but the Robox does have its limitations. At this time, we're recommending, or I'm recommending, simple tooth-supported guides with the Robox, whereas the Form 2, you can print pretty much any type of guide. The accuracy is there, where we've had extremely good success with printing any type of guide today. And that slide I showed earlier showing the different types of cases, the different types of restorative options that we teach at our comprehensive implant course, you can produce a surgical guide for any one of those types of cases, including some of the bone grafting procedures, such as a sinus graft. You can make a sinus graft guide, etc. So the idea here is, with the Robox, it's somewhat limiting, but for folks who are just getting started or who have only the need for simple tooth-supported guides, the Robox is a great option to start. And the Formlabs will produce basically any type of surgical guide. With the Robox, you do have to cold sterilize the guides overnight, so it sort of prevents you from doing same-day guided surgery. Whereas with the Formlabs, technically you can autoclave the guides. Now there are some restrictions on how you can autoclave them, but you can find that from Formlabs themselves. They'll give you some guidelines. But we have used guides same day. In other words, we have the patient come in the morning, do the workup, print the guide, and in the afternoon or the evening we can actually do same day guided surgery, because we're able to autoclave the guides from the Form 2. As far as printing models, the best resolution you're going to get from the Robox is about 100 microns, which is certainly more than adequate to make surgical guides. Whereas the Form 2, with some of their resins, you can print very accurate models down to 25 microns. We actually just got some of their new gray resin in, and we tested it, and we were able to get very, very accurate, close to 25 micron accuracy with their new gray resin. So if you're doing clear aligners, for example, you'd want to be doing them with a Form 2 and not with a Robox, at least the models. And that's something we're doing quite a bit of now in our practice. We're making our own clear aligner models and doing clear aligner cases literally for about $300 or $400 per case, as far as the fee to print the models and do the clear aligners. And we hope to have a course on that upcoming, probably by the end of the summer. We'll put together a course on that as well. So those types of cases, you'd have to be using a Form 2. For the Robox, if you're printing a single guide versus multiple guides, the Robox versus a Form 2 for a single guide is about the same speed. Actually, the Form 2 on some guides will take a little bit longer for a single guide. But if you're printing multiple guides at a time, or models, let's say for clear aligners, then the Form 2 does have a time saving when you add in multiple guides. Okay, so going back to what to buy, let's say you decide now to upgrade from a Robox to a Form 2 printer instead, and you add, with your guided surgery kit, you're looking at about $7,000, and again, your cost per guide will go up a little bit with the Form 2, but not that significant. Your Blue Sky processing time is going to stay about the same, 35 to 45 minutes of actual software time. Some of us can do it faster, but that's probably an average per case, depending on the case, of course. Again, here you're assuming you have a CBCT unit already. You have your own computer that you can use to run the Blue Sky software, and you can, assuming you've learned everything online or already taken a course. There are some additional accessories that you'll probably need to buy with the Form 2. you'll need a PostCure oven. After the prints come out of the Form 2 printer, you will need to do a post-cure with a UV light. There's several ways to go about doing this. One is, of course, the most economical route is to get yourself a nail star curing unit. You can get one of these on Amazon for about 30 bucks. The drawback is that it's going to take about 2 to 3 hours to do the post-cure on the Formlabs guides. Now, what you see in the middle of the screen here is what the guides look like, and there's a color change that occurs after the post-cure is done. And that color change is built into the guide, into the material, so that you know that you have biocompatibility with their resin. Once the post-cure is done, the guide will actually turn from a bright yellow color, which is how it's printed initially, to the post-cured color, which is a very orangish color. And then, you know, once it's sterilized, it'll actually go to a clear color if you do autoclaving. If you cold sterilize it, it doesn't change color, it'll stay a bright orange color. But the idea here is you need to buy an additional post-cure light or oven that will allow you to do the final cure on the Form 2 dental SG resin or surgical guide resin, so that it is biocompatible for intraoral use. You don't have to do this with the Robox, because the Robox printing technique does not change the characteristics of the filament that's the raw material for the Robox printer. So the filament is actually already okay to use intraorally for you know, short periods of time, like surgical guides. But with the Form 2, the actual printing process is a light curing process, which changes the characteristics of the raw material, which is a liquid resin. Now, I had been recommending like a Triad oven or a ProCure oven, which you can get from a dental dealer. Those sell for about $500. But I actually discovered a new oven that's out there that's great. It was made and designed specifically for the Form 2 post-cure. It's sold by a company called Burton Randall, and I'll have their information on the next slide, but it's about a $700 cost to buy this oven, but it'll cure the Form 2 guides in about 20 minutes. So it was developed by a small company called Burton Randall here in Florida. And this is a picture of this oven. So this is what we're recommending today. You can go to their website, burtonrandall.com, for about $700. It's great because you can put multiple models or guides in this oven at a time. And you can see it has 2 turntables that automatically start turning, so you get the full curing on this on your guides and models. One of the problems that we ran into with the ProCure, and I expect that you'll have the same problem with the Triad oven if you're using that now, is that the darker resins, such as the new gray high-resolution resin from Formlabs, will melt in those ovens. I'm assuming it's because of the darker resin absorbing more heat from that light source, which is a halogen light source, whereas this oven and the nail star oven use a LED light source, so it doesn't generate as much heat. But again, this is the oven we're recommending, and you can get that from a company called burtonrandall.com. And what I say is support small business. It comes with a 1-year warranty, and it'll get the job done efficiently for you. Very minor cost when you look at the big picture. An additional thought on using Blue Sky Plan and being efficient at what you do is get the biggest screen that you can. You know, I did mention the laptop with the 17-inch screen. If you're going to use a laptop, I do recommend you get a 17-inch screen. After teaching these courses on Blue Sky and other software for a few years now, it's important, you know, what you're seeing on the screen, the size of your monitor is your interface to the software. So make it easy on yourself. Get a big screen. Now, if you're doing it on a computer in your office, you're doing your planning, go ahead and get yourself a large monitor. Get a monitor of 27 inches or larger. 32-inch would be even better. You know, whatever you can afford, but it allows you to see and do things more efficiently in a larger workspace. As far as computers, this is another question I get asked quite often. You know, what type of computer, what are the specs on a computer that you should be looking for? You know, what I recommend is a Windows PC. We have had some issues with Macs in the past, although I understand with this new build of the Blue Sky plan, they've addressed a lot of those issues. But we use a Windows PC. I would recommend you get a Core i7 with 16 gigabytes of RAM, an NVIDIA 1080 GTX video card with at least 4 gigabytes of video RAM. So it's a dedicated video card, 4 gigabytes of video RAM, a 1 terabyte SSD drive, because as you start to do plans, you know, it's going to get filled up. And I recommend, if you're using a desktop computer or having a computer built for this purpose, get the latest technology SSD drive, which is M.2. And by the way, that laptop that comes with the new CS3600 has a M.2 SSD drive, and it's really fast. And of course, get a scroll wheel mouse. You know, that middle wheel is going to allow you to do a lot of the functions in the Blue Sky plan. And that's something that happens every so often at our courses. Folks bring a Mac mouse or a mouse without a scroll wheel in the middle, and they have trouble using all the functions of the software. So just some additional thoughts that might be helpful for folks. You know, if you're going to get a computer, go ahead and get one that will allow you to run the software efficiently so you don't get frustrated, and it'll be more of a pleasure planning your cases in the software. So that said, let's actually look at some cases. So here's a case. Actually, it's a case that we're doing some additional implant placement on, and this is a case we actually did last week Saturday, just a few days ago. As part of our course, we did a live surgery, part of our Blue Sky Plan 3D printing course. We did a live surgery where we actually used a guide that we 3D printed to place an implant. So this is a patient. You can see actually there are 3 Biomax implants already placed on the right side, and now we're going to go over here and place an implant on the left side of the patient, the tooth number 12 position, or sorry, 13 position. So we go ahead and, you know, bring in our CBCT data set, and in this case we actually brought in an impression scan of the patient, and we calibrate it. You can see on the back part of the scan we have an indentation there. We calibrated that scan using Hiroshi Takagi's calibration cube. If you don't know what that is, go online and you can find out more about it, or send me an email. I'll give you the information. But the idea here is that you can use this calibration cube and actually calibrate the threshold settings so that once you pull in the CBCT scan of the impression to create the STL file, you'll have the proper threshold. And I was just informed by Michael that the new version of Blue Sky Plan actually allows you to set that threshold. So if you're using the same CBCT settings and the same VPS impression material, this should just be a one-time calibration. As long as you use the same settings for your impression scan and for your VPS, the same VPS material, you'll be able to hold that threshold setting and make the process go faster. This is, again, in lieu of having an optical scan. So we bring in the impression scan as a DICOM. We used a digital pour technique, which is something that I developed, and actually they've incorporated this into Blue Sky. And then we can invert that impression into an STL model that you see here in green. We can then use that and bring in a virtual tooth and actually plan the implant using a virtual tooth in the Blue Sky plan. And another thing that I just posted a video on, if you go on YouTube, you can see the video on this, is how to actually scan a bite, how to take a bite and actually scan the bite using Blue Moose or similar impression material. You can take a VPS bite, scan it on the CBCT. You could actually scan it on the same scan that you scan the impression. And then you can actually take that in the mesh mixer and invert that into a actual bite, bring that back into Blue Sky Plan, align it with the maxillary model, which you typically would have already aligned to the jaw scan. And then you can actually align the lower impression so that you can actually bring the occlusion into the whole scheme of things and plan your implant accurately. Now, in this case, we actually did that. We brought in the lower using that impression technique, and you can see this is the view from the bottom here of the lower jaw. We're actually aligning the implant so the occlusal forces are aligned on the buccal cusp of the opposing tooth. So this gives you really a lot of control for a very precise, prosthetically driven, guided implant placement. And the next step, of course, is to design the guide. But before we do that, I want to show you how accurate the reverse impression technique is, the inverted impression technique. What you see here is a video showing, as we go through the slices, the red line is an actual optical scan of the patient, and the green line is an impression, a VPS impression inverted. So you can see by properly calibrating the threshold and developing that threshold technique, you can actually get a very, very accurate STL file generated from an impression. So those of you who don't have an optical scanner, you can basically get the same result by scanning your impression. And again, going back to the slides I showed before, that's going to add 15 to 20 minutes to your processing time. But you know, again, it's something you can do. This whole process can be done without optical scanning, but you do have to have a CBCT. So once we've planned the implant, we put our guide tube settings in, and we actually create the guide. Now in this case, because I had done an optical scan, we decided to do a test. What we did was we created several guides, actually. We created two guides, one from the inverted VPS impression, STL file generated from the inverted VPS impression. And then we created a second guide that was created from the optical scan. We wanted to see what the accuracy of all of these different techniques were. And then we went one step further. We printed both of those guides, again, one from the optical scan and one from the VPS impression inverted in the Blue Sky Plan software using the digital pour technique. We printed both of those guides, one of each, on the Robox, and then we printed both of those guides, one of each, on the Formlabs printer. We then printed some models. These are actually from the optical scan because that's got the highest level of accuracy. And then this is what the model looks like after it was printed on the Formlabs printer. We then went ahead and tried these guides on, and you can see this is a guide made from the optical scan, printed and placed on, printed in the Formlabs printer and placed on the model. You can see the very high level of fit, of accuracy of the fit. This is the same guide from the optical scan printed on a Robox, and you can see also a very high level of accuracy and fit. Then we did the VPS generated guide and printed that on the Formlabs, and again placed it on the same model, and you can see again very, very high level of accuracy of fit. And then this is the same guide using the VPS impression technique placed on the model as well, printed on the Robox and placed on the same model generated on the Formlabs. Now, the bottom line here is all of these techniques are valid techniques and will give you a very similar level of accuracy, whether the guide is printed on a Robox or printed on the Formlabs. We actually did the surgery using one of these guides. I can't remember which one, but we did the surgery live, and we actually placed all four of these guides. Of course, we sterilized them, but all four of these guides were placed in the patient's mouth, and the people who were there live during the surgery got to see how all of these guides fit accurately and would give us the same accuracy as far as our implant drilling and implant placement. So we placed the implant using the guide, and what we did here was we did a post-op scan and then did an overlay. What you see here in this image is the yellow is where the implant was planned, and the white is where the implant actually ended up. So we took the plan STL, exported it, and brought it into the Postop CBCT image, and then overlaid it. And you can see here, and we'll go through the slices and show the very high level of accuracy. We're going through the slices on the axial plane here, and you can see very high level of accuracy of the placement, which was done with an in-office 3D printed guide. We're going to go through now the tangential views, and you can see we're off by maybe 1/4 of a millimeter in some respects, but a very, very high level of accuracy with these types of guides. We'll let this just finish here. You can see again, look at the overlay there on the tangential view, and here as well in the cross-sectional. So all of these techniques are valid for guide fabrication and implant placement. Of course, you do have to check yourself each step of the way. Make sure that your STL alignments and merges are accurate. Make sure that your guide tube settings are correct. And like anything else in dentistry, you'll have a good result. Okay. So one of the things that has been a topic on the forum recently has been bone reduction guides and using Blue Sky Plan. And I know the team at Blue Sky are working on, in making bone reduction guides easier as well. They're working on a lot of things actually, but that's one of the things they're working on, making bone reduction guides so you could actually do cases like this where you do extraction of all the teeth, make a bone reduction guide, and then place the implants. But, in my mind, simplicity is sometimes the best remedy. So in this case, for example, what we're planning to do here is, since we have the ability in our practice to make make the guides in office for a very low cost, there is another way to look at and approach some of these cases. Like in this case, what we decided to do was actually make 2 guides. Since it is so easy to generate a second guide, we actually decided to make 2 guides. So in this case, we're not doing a bone reduction guide. We're not doing a guide that's maybe 2 pieces that snap together. We just simply are making 2 guides, and for ease of use and simplicity, sometimes this is the best way to go. So the plan here is to go ahead and bring in our STL merge. We then bring in our prosthetic wax up. In this case, the patient was wearing a partial denture, so we brought that in. And then we planned our implants. And here we're doing 4 implants for some sort of fixed restoration. And where you see the implants planned is where we actually had enough bone to place the implants. But the idea here is using the prosthetics to guide the implant placement, as well, of course, as the amount of bone remaining and the patient's anatomy, staying away from the nerves and such. So what we did here, we're planning the implant to go ahead and plan all 4 of the implants. We then take the tooth model and design a guide on that tooth model so the guide would actually fit on the existing teeth. So here's what it looks like. We design a guide to fit on the existing teeth. And with this guide, we're going to go ahead and place the first 2 implants, which are in the number 25, I think 23 and 25 position, or 26 positions. And then we will actually take this guide out and digitally extract tooth number 20 and tooth number 27, and then quickly design a second guide. So because of, again, of our ability to in a very low cost way, produce a second surgical guide, we produce a second surgical guide now, which would then be placed after the extraction of tooth number 20 and tooth number 27, because that's where we need to drill to place our additional implants. The guide is still seated on some of the remaining teeth, but you could also fixate the guide using various techniques to the implants that were already placed. So it gives you a good stability for the guide, and then you can go ahead now and drill the other 2 distal sites and place the implants. So again, here's what the first guide looks like, and then the second guide with the digital extractions. so that you could take out the teeth and then seat the second guide and drill the additional areas. So you don't need necessarily bone reduction guides. You don't need, to have snap-on type guides. They're certainly great, and if you have the ability to produce those or use those, that's great. But sometimes, in certain cases, simplicity is the best remedy, and you can just generate 2 guides instead of 1. And again, if you're doing it in office, you can do it for a very low cost way of doing things. Of course, we use the Formlabs printer to produce that type of guide. It's going to give us probably the best accuracy for that particular type of guide. One of the things that I would like folks to do is showcase the technology that they have in their practices. There's a lot of buzz in dentistry now about technology. And, if you listen to the radio, you'll hear ads, for example, from 1-800-DENTIST talking about CEREC and, how dentists now have the ability to do crowns in one visit using CEREC. And you can call 1-800-DENTIST and, they can direct you to a CEREC office and such. Now, we don't do CEREC, but, we do showcase the technology. And this is something that will help with your case presentation and case acceptance. So put your 3D printer in a place where patients can see it. And a lot of folks out there actually are learning about 3D printing now, especially families that have young kids where they're talking about it at school and such. And let your patients know that, that you have a digital laboratory in your office where you can do things in-house with a higher level of precision, a high level of precision and speed, and you can do things, in one day. So this is one of the things we've done. There are a lot of patients I've actually shown the 3D printers to, and the next patient is actually one of those. So this is Randy. Randy came in and he had to have a tooth extracted, and actually we end up doing a immediate extraction, socket graft, and sinus graft procedure to get enough bone to place implants. So we took the tooth out, removed the lesion that was there. You can see there was a very large lesion. And then inside of that lesion, we went into the lateral window of the sinus and did an additional sinus lift so that we could place an implant distal to where the socket was here. So we did this all as a combination procedure. Now, we let that cook for about 4 months. Here's a sinus graft procedure. We let that cook for about 4 months. And one of the things that Randy had a bridge there originally, and one of the things he asked me to do was leave the first premolar so that when he smiled, it wouldn't be so obvious that he was missing a tooth. And I said, sure. So we cut the bridge and left the pontic hanging off of the canine there. And when he came back in 4 months, our plan was to go ahead now and cut that pontic off so we would have access to place our implants. Well, Randy came in and we got to talking, and one thing led to another, and I ended up showing him the 3D printer. And he came in actually for a post-op on his sinus graft. We took our CBCT, and there's the sinus graft we had done. You can see very successful lateral window approach sinus graft, lots of bone. And interestingly, he came in the morning, and he actually told us he had taken a day off. So would we be able to place the implants that day? Now, he was only there for a post-op. But given that we have the ability to produce surgical guides, we said, sure. So we went ahead, and actually at the time we were using a Robox printer just to do model-based guides. And that's what we did. We went ahead and produced a model-based guide and used it that day to place his 2 implants. We're actually going to place 3 implants total here, but we actually were able to place 3 implants, and we left the pontic tooth in place because Randy wanted to keep that tooth there as long as possible. And then, after everything healed and the implants integrated, we then are now going to transition him to a temporary on the 2 implants we first placed, and then take out the pontic, as you can see we did here, and place a 3rd implant. Now, the 3rd implant, because we had the advantage of planning and time, we actually went ahead and produced a Robox guide for that 3rd implant, which allowed us to align the implants to this 3rd implant to the other 2 implants that were placed previously. And then we were able to use this and place the implant through the guide as well. Now in this case, we could have done it flapless. You know, I do a lot of teaching, so we actually opened just a minimal flap here to check the accuracy of our guide, and also to get the picture for teaching cases and such. And we went ahead and placed the implant. You can see how accurate the guide was. And then we just basically sutured the tissue back together. Of course, he had a lot of thick keratinized tissue. You know, a case like this, using surgical guides now that are so accurate, there's no need to lay a flap. We could easily have done this flapless. But the same day that we placed that third implant, we had cut off the pontic, and we're now actually, we had a temporary fabricated and ready to go, a screw retain temporary, so that Randy was able to leave now with the tooth in that premolar position. That way we were able to give him what he wanted, which was the aesthetics of not having to walk around with a missing first premolar. And now he's got all three teeth back, basically. We let that third implant go ahead and integrate, and once that's integrated, we go ahead and make the final restoration on 3 implants, and that's what you see here. Nice zirconia restorations on 3 implants. I believe these are also screw retained. So just to finish up now, I want to talk a little bit about, you know, I mentioned before that it's a good idea to go to a course. We do give a course on 3D printing surgical guides using Blue Sky Plan, and actually on both printers, the Robox and the Formlabs. So if anybody's interested, these are some of the things that we teach at the course. There's a lot of software training, but there's also hardware training. You know, bringing in the DICOM data sets, tracking the nerves, aligning STLs, bringing in an optical scan, adding virtual teeth, loading the prosthetic wax-ups if we have one, or using virtual teeth nowadays. Now that we have the ability to bring in the occlusion, the opposing occlusion, virtual teeth now take on a whole new light, because we can put in virtual teeth that are fairly accurate. We can plan the implants, put in the offsets and the sleeve settings, draw the curves for the guide, and create our guide. There are additional things, such as bringing in scan appliances for patients that have a lot of metal or zirconia crowns in their mouth, or PFM crowns. You know, how to calibrate the impression rendering, invert impressions, align inverted meshes, create windows in guides to allow us to ensure the proper seating of the guides, fixing mesh errors in the guides, using Mesh Mixer to do digital extractions, custom print settings, what I call now rapid settings or rapid print settings in the Robox and the Form 2. I know there's a lot of buzz out there about printing without supports and such. There is a lot of pre-processing before you send it to the 3D printer when you do supportless printing, and you know, also for either Robox or Form 2. So we've come up with what we call quick settings for getting the print from the Blue Sky software to the Form 2 or the Robox as quick as possible. So we've developed some custom print settings using supports, because we believe that using supports gives you the most reliability with your prints, as far as the prints going well and not having a failed print, and also for the dimensional accuracy of the prints. You know, both of these printers come with the ability to do supports, and the engineers at Robox and at Formlabs have worked out some very good settings. Now we've customized them a little bit for what we do. The settings that they actually use and allow you to use in their software are for doing all kinds of different printing. But we have some custom print settings that we have developed that allow you to go quickly from exporting from Blue Sky Plan to starting your print. And as they say, time is money. You know, the least amount of time that you can spend post-processing these guides and getting them out to the printer, the better. And of course, when you come to a course, there's discounts on products and much more than what I have that I can talk about here and put in these 2 slides as far as what you're going to get by coming to a course. So I will plug our courses. We do have a course coming up in New Jersey, March 17th, which we're doing at the Smile Syllabus Training Institute, which is Jonathan Abenheim's facility that he recently built for teaching digital dentistry. He's a very talented digital dentist, and I'm looking forward to actually learning some of his techniques on milling and designing for milling at his facility. But we're having our 3D guide course there, our 3D course, on March 17th. We also have another course coming up in Fort Lauderdale on April 1st, where we actually do a live surgery, just like I showed in the case before, where we'll actually go through the entire day of training, and then we'll actually go over to the office and do a live surgery, showing how to use a surgical guide with a guided surgery kit. And then we have an optional second day where folks can actually, one-on-one, we'll teach them how to go through all the steps in the software and actually print a guide. So they'll leave with a guide they can actually use on a patient. And then, of course, we do some things internationally. I am teaching the 3D course in Taiwan. I know this webinar is going to be viewed internationally as well. So April 16th, I'll be in Taipei teaching the guided surgery techniques with Blue Sky Plan and the robots and Formlabs printers as well. So I look forward to seeing one of you at our courses. There are a lot of, certainly a lot of online resources, and we have Blue Sky to thank for that allow you to learn a lot of these techniques. And I know a lot of you are technical enough that you're going to go online and learn it yourself, but I hope you'll still think about coming to one of our courses, maybe for refinement of your skills and such. So here's my contact information. I thank, again, Blue Sky and Michael for giving me the opportunity to be a part of this revolution in implant dentistry. And I thank you so much, and please feel free to contact me with any questions. Michael, is there a question and answer session at the end here?
Yes, there is some time for questions. So if you have a question, type it into the chat box, and we'll see if Dr. Ferguson could address them. One question that came in, which you did touch upon.
I can't see the questions, by the way.
Okay. One question that came in that you touched upon previously. Somebody wrote, I'm a relative newcomer to Blue Sky Bio, but was wondering about the pros and cons of the one-cut system versus the fully guided kits.
I think the one-cut system was fantastic. I will say that using the one-cut system, I think a lot of people are, who've used a one-cut system are going to transition probably over to using the fully guided kit because of the accuracy. I do believe that the new fully guided kit is more accurate, and also the fact that you can place the implants through the guide instead of in the old way having to produce a separate implant placement guide. Excuse me. With the one-cut system, you had to use additional guide tube settings in the software, which are somewhat difficult to print on the robots. You can actually print them fairly well on the Formlabs, but they're, depending on the angle of your printing, they were somewhat difficult to print. And I do believe that folks should really consider transitioning over to the fully guided system. Whatever implant system you're using, by the way, I don't think it's for any particular system, but you'll notice that pretty much all the implant systems have gone over to fully guided kit for that reason, that also allow you to place the implant through the guide.
Okay, do you advocate using a guide sleeve with the new keyless kit or without one for the kit?
Yes, I do advocate using a metal sleeve. There are several reasons for that. Probably the most important reason is liability and safety for the patient. I do think that there is a chance that the drill can cut into the plastic, and then you'll have pieces of plastic embedded on the drill and possibly contaminating the osteotomy as you place your implant. I'm not sure if there's any evidence to show that that would be true, but I will also say that since we've been teaching guided surgery for a while now, with literally hundreds of doctors have come through since in our comprehensive course that we've been teaching, guided surgery mainly or only. as the beginning steps to implant placement. I will say that, you know, sometimes the doctors will put the drill off angle a little bit into the sleeve, and, you know, you can get the drill caught up in the sleeve. And it's important as part of your learning curve. So if there is no metal sleeve, what can happen is that, you know, again, you can cut into the plastic if you're a little bit off angle with your drill. So I highly recommend using the metal sleeve. The other thing to consider, though, is the friction between the metal drill and the plastic is going to be much greater than the friction between the metal drill and a metal sleeve. So there's much greater chance of the drill binding into the plastic sleeve versus a metal sleeve. So I'm a big advocate of using metal sleeves for guided implant drilling.
Yes, Blue Sky Bio also recommends that protocol as well. We don't recommend using a surgical guide without a metal cylinder.
Yep.
Can you repeat the name and the technique of the calibration tool for the impression process, the impression technique?
There's a calibration cube that Hiroshi Takagi developed. It's his technique, and I applaud him. It was a brilliant stroke of genius on his part. What it is, it's a cube that you put into the impression material that gives you a known reference object in the impression that you can then bring in when you bring the DICOM into Blue Sky Plan, and it creates the 3D rendering. You can move the threshold slider until you see these two cubes. It's a positive and a negative cube, and Hiroshi has a video online, I believe on YouTube, on how to do that technique, which I highly recommend if you're using the VPS impression inversion technique. So you can get that calibration cube. I have the STL file. You can have it printed. You're going to print that. Make sure you print it on at least a Formlabs printer or a high-level printer, because it needs to be very precisely printed. You wouldn't be able to print that with high enough accuracy on a Robox printer. But those cubes are available. I know Barry Volts has those available as well at Digi3D Works. But you know, get in touch with Hiroshi about that as well. He was kind enough to post both the STL file for the calibration cube and his technique. And you know, it's a wonderful technique building on what I developed as the digital pore inversion technique. It was the way really to get the digital pore technique to be very objective and very accurate. Okay?
Just to add a point and explain, Dr. Ferguson is referencing different posts that are happening in the Blue Sky Bio Academy Facebook group. The Facebook group you could join, you could request to be joined just to make sure there's no spamming, there's an approval process. But the group is a fantastic group of many very knowledgeable people who are generous with their time, providing feedback on cases, providing great ideas, and are really doing cutting edge cases with amazing techniques. And a lot of the techniques being done there end up being integrated into Blue Sky Plan, such as Dr. Ferguson's impression inversion technique, which started out as an idea that he proposed, and it was a fantastic idea, and we went ahead, excuse me, and implemented it into Blue Sky Plan. So you could search on Facebook for the Blue Sky Bio study group, and it's highly recommended to join that group. It's a tremendous asset.
Absolutely, the folks on there, you know, you got Corey Glenn on there, Marco Tadros, Baron Grutter, Armin Mizrain. I mean, just amazing people who have put their time, you know, made their time available to help folks and to learn these techniques, and have come up with some really innovative ways of using Blue Sky Plan.
Let's just finish up with one more question. Have you had trouble with the accuracy of the Robox printer, and how can I get the custom settings?
I do sell some custom settings, which is more than just a setting. It's a short video that shows you how to position the guides for the most accurate printing. You know, I created that video with those settings because I did a lot of experimentation on the Robox, and that's why I know the limitations of the Robox, But if you're interested in getting those settings, you can just simply email me, drferguson@aol.com. There is a small fee to purchase the video, but I definitely think it's worth it because I spent about 300 hours developing the Robox printer and coming up with those settings and the positioning for the guides and such. And I know the accuracy is extremely good the way that I do it in that video. Okay.
Okay, just to wrap up with a few comments that I mentioned at the beginning, this is the first of a 2017 webinar series with a variety of fantastic speakers on different topics in surgery. So definitely recommend staying tuned. We have information on our website and we send out emails as well in presentations. I'm going to be giving a presentation next week on some of the new functionality in Blue Sky Plan and how to integrate the fully guided keyless kit in a new version of Blue Sky Plan that's actually uploaded to our website today. So that's available for download as well. And you'll be getting notifications within your software in the next couple of days to upgrade and update, of course, at no charge to our latest build. The webinar series is also being done in conjunction with biobigbox.com, which is a HIPAA-compliant file transfer and storage system, Blue Sky Plan, and developed by Blue Sky Bio to handle the large amounts of digital data to back it up, all HIPAA compliant. So we recommend checking out biobigbox.com, and we are offering a 50% discount in conjunction with this webinar series. When you check out, you can enter coupon code BSB 2017 webinars. Make sure to enter your details into the webinar attendance form, CE credit for attending this webinar presentation. Okay, I think that really wraps up the presentation. Dr. Ferguson, I want to thank you as always for valuable information and sharing your ideas with the Blue Sky Bio community and your ideas with us to help us advance Blue Sky Plan. To thank everybody for attending and wish everybody a good evening.
Thank you.